Welcome to this video. In this video, I'll be going over exponential functions. So I'm going to start by introducing the form. So how do I know if the equation or the function that we have is an exponential function? So typically, let's say f of x, our function f is equal to a to the power of x. So this is how a typical exponential function would look like. Okay, so here this is my base. And you can see that my variable is the domain. This is my exponent. Right, my variable is the exponent, and I have some value a as the base. Okay. Now, but there are a few things that that we need to be careful with for the base. My base has to be positive. Okay, so a must be greater than 0, but at the same time, my a cannot be equal to 1. And that makes sense because let's say if I have f of x is equal to 1 to the power of x. Okay, and then if I make a value, a bunch of x and y's, if my x is equal to 0, then I have 1 to the power of 0, which is just 1. If my x is say 2, then I have 1 to the power of 2, that again is 1. If I say my x is equal to 3, then 1 to the power of 3, again, that's 1. So if my base becomes 1, then I'm just going to keep on getting these y values as 1, 1, 1, 1, 1, right? And that's not very intriguing in any way, right? So this would not be an exponential function because we have this 1, 1, 1, 1, 1, just keep on repeating. And that actually looks just like that. For all x values, my y value is simply just 1. Okay. So keep this in mind. Your base for any exponential function cannot be 1, and it has to be positive. Now within this positive a greater than 0, we can break it down into two different categories. The first one, so if you say that a cannot be 1, but then maybe can a be greater than 1, right? So maybe something like, can my a be equal to 2, 3, 5, whatever, right? Any value that's, or even something like say 3.5, that works, or 2.2, that works as well. Any value that is greater than 1, that would be my first category. My second category would be, it has to be positive, it cannot be 1, so what about less than 1? So my a value can be something that is positive but less than 1. Another way to say that would be possible ones. Well, my a could be maybe half, my a could be 2 over 3, my a could be 3 over 10, right? So it's pretty much a proper fraction that is less than 1. Okay, so my a value, the base, could be one of these, a greater than 1 or between 0 and 1. Okay, so I'm gonna start with this one. I'm gonna start with my base greater than 1, and I'm gonna switch to decimals to show you guys how the graph looks like. So I will encourage you guys to put these equations in on decimals. Alright, y is equal to 2x, y is equal to 3x, y is equal to 10x, and let's see if we can try to come up with a shape of a typical exponential curve. Okay, so I'm gonna pause the video and switch to decimals. Alright, so here I have open up my decimals, and I have y is equal to 2 to the power of x, y equals 3 to the power of x, and y equals 10 to the power of x. The red one, this one over here, this red color one over here, this is a 2 to the power of x. My blue one is the one with the base of 3, and the green one is the one with the base of 10. So if you look at this, we see that the shape of all of this 3 exponential curve exponential graph, they all look somewhat like a, it would be in this kind of shape. The shape is pretty much something like that. Let me redraw that. Something like this, right? And that is the general shape of an exponential function where your a is greater than 1. Okay, so if you want to try it, we can try with, let's say, 2.2 to the power of x. So let's try that. So instead of having pretty values like 2, I'm going to try to have, say, 2.2. So let me hide the blue one, the green one. So the red one is the only one that we want to see. And as you can see, it didn't really change much in terms of the shape, right? We still have this sort of flat on the left hand side, and then as we go to the right, it becomes steeper and steeper, right? However, there's one thing that I would like to point out. Let's look at y is equal to 3x, and let's hide this one. Let's hide the red. All right. You know what? Let me actually show you guys something first. Okay. There's one special point that all of these three curves passes through. They all pass through this 0, 1. Can you think about it? Can you think about it? And why do you think this is true? This is happening. If you think about this, at this point, my x is equal to 0. So if I put the 0 into my x over here, if I put the 0 into x over there, if I put the 0 in my x over there, is anything to the power of 0 is 1. So this point would be the y-intercept for these exponential functions, right? That makes sense, right? So there's another thing. So there's not something else that I would like to point out for the exponential graph. If I kind of go towards the left hand side, and if I zoom in, you can see that this line, it seems like it's gonna touch, it's as if it's gonna touch the x-axis, but it's not really gonna touch at all, right? So even though as I move to the left, it gets closer and closer to it, but every time when I zoom in, I can actually see that the line doesn't really touch the x-axis. Okay, so which means we have a horizontal asymptote, and since the horizontal is a horizontal asymptote, my equation will be y is good. And the horizontal asymptote for now seems like it's at the x-axis, so my y is equal to 0 is the equation of my horizontal asymptote. Okay, so let me go back to my sketch. So here, this is what I have here. This is the general shape of an exponential curve when your a is greater than 1. And don't forget that we will have the horizontal asymptote on the x-axis. We will have a horizontal asymptote, but in this case, the most basic exponential functions, the graph would be similar to this. And if we don't have any sort of transformation, then the horizontal asymptote would be on your x-axis. Okay, but if we do carry out some sort of transformations, which we will talk about later on, then the horizontal asymptote will be changed. So now that I know my horizontal asymptote is there, what's my domain? My domain would be from negative infinity all the way to positive infinity. What's my range? Horizontal asymptote, it has a connection with my range, right? And vertical asymptote, this is a side note, vertical asymptote has something to do with my domain, and horizontal asymptote has something to do with my range. So in this case, my range would be, my y value can never be 0, so 0 with the parentheses, and then it's going to go all the way to positive infinity. So this is my domain and range of a basic typical exponential function. Okay. All right. I think I will make another video where we will be going over this type of exponential functions between where my base is a fraction. Okay, I'll be talking about that in the next video. Okay, feel free to rewind, and I'll see you in the next video. Bye bye.